Hello everyone, and welcome. Today we are diving straight into the operating system that powers the internet, Linux. Whether you are aiming for a career in DevOps, cloud engineering, or software development, this is your starting line. In the next 5 minutes, we are going to cover the 15 essential concepts that will take you from a beginner to a confident Linux user. Let's get started. First, you might ask, why Linux? The answer is simple: dominance. Over 90% of the public cloud infrastructure relies on Linux. Unlike consumer operating systems, Linux is open source, incredibly stable, and designed for automation. When you launch a server on AWS, Azure, or Google Cloud, you aren't looking at a desktop. You are interacting with a Linux environment. It is the industry standard for a reason. To understand Linux, you have to visualize its architecture. Think of it as a layered system. At the very core, we have the kernel. This is the brain that talks directly to your hardware, managing memory and CPU. Wrapped around that is the shell. As a user, you never touch the hardware directly. You type commands into the shell, and the shell translates your requests to the kernel. For DevOps, the shell is where we live. If you are coming from Windows, forget about the C drive. Linux uses a single, unified file system hierarchy that starts at the top, known as root, represented by a /. From here, everything branches out like a tree. You have /bin for your programs, /etc for configuration files, and /var for variable data like logs. Knowing where things live is half the battle in system administration. Since we don't usually have a mouse in a server environment, we navigate using text commands. The three you will use every day are pwd, which tells you print working directory or where you currently are, ls to list the files in that folder, and cd to change directory and move around. Mastery of the command line starts with being able to move through the system fluidly. Once you can move, you need to be able to build and destroy. We use the touch command to create empty files and mkdir to make new directories. On the flip side, we have rm for remove. A word of caution here: the command rm-rf forces the deletion of files and folders without asking for confirmation. In DevOps, this command is powerful, but dangerous. Use it wisely. A massive part of DevOps is troubleshooting, which means reading logs. We have several tools for this. Cat dumps the entire file content to your screen. Less allows you to scroll through long documents page by page. But the most important for us is tail-f. This follows the end of a file in real time, letting you watch server logs stream by as errors happen. Linux was built with security in mind. Every file has a set of permissions determining who can read, write, or execute it. You will often see these represented as R, W, and X. If you try to run a script and it fails, it's often because you don't have the execute permission. We use the chmod command to modify these rights, ensuring only the right users can access sensitive data. By default, you are a standard user with limited access. This prevents accidental damage to the system. However, when you need to install software or change system settings, you need the powers of the administrator, known as root. We access this power temporarily using the command sudo, which stands for superuser do. It elevates your privileges for a single command. In Linux, we don't browse the web to download installers. We use package managers. Think of them as an app store for servers. Depending on your version of Linux, you will use tools like apt or yum. You simply type apt install, followed by the software name, and the system automatically fetches and installs the latest secure version for you. Now we get to the real magic: piping. Represented by the vertical bar character, the pipe allows you to take the output of one command and feed it directly as the input into another. This lets you chain simple tools together to build complex workflows. For example, you can take a massive log file and pipe it into a filter tool to instantly isolate the data you need. Speaking of filtering, meet your new best friend, grep. It stands for Global Regular Expression Print. In simple terms, it searches for text. If you have a log file with 1,000,000 lines and you only care about the errors, you simply type grep, followed by the word error. It scans the file and prints only the lines that match. It is indispensable for debugging. Speaking of filtering, meet your new best friend, grep. It stands for Global Regular Expression Print. In simple terms, it searches for text. If you have a log file with 1,000,000 lines and you only care about the errors, you simply type grep, followed by the word error. It scans the file and prints only the lines that match. It is indispensable for debugging. Sometimes, applications crash or freeze. To manage this, we use process tools. Top or htop gives you a real-time dashboard of your CPU and memory usage, showing you exactly which programs are hogging resources. If a program is stuck, we use the "kill" command to terminate the process ID and free up the system. Finally, we bring it all together with scripting. DevOps is about automation. Instead of typing these commands one by one every day, we write them into a file called a bash script. This allows the computer to execute complex sequences of tasks automatically, perfectly, every single time. This is the first step toward infrastructure as code. This comprehensive summary highlights the core Linux essentials for DevOps: file system mastery, security and packages, and advanced tools like piping and process management. Thank you for watching this video.